Hello everyone, welcome to another short video on solving a LeetCode problem with APL. In this video we'll be tackling problem 1342, number of steps to reduce a number to 0. And what this says is, let's define a process. So when we receive a number, if the number is even, we divide it by 2, and if the number is odd, we subtract 1 from it. And we do this, and then we need to count the number of steps it takes to transform a number, our original number, to 0. So 14 is even, so we divide by 2 and get 7. 7 is odd, so we subtract 1 and get 6. 6 is even, we divide by 2 and get 3, etc, etc. And so to solve this, maybe, at least for me, still the first solution that comes to mind is a simple recursive solution that just counts the number of times it needs to go down. So I would just do something like the number of steps, maybe. So ns for the number of steps. What it does is, if the number is equal to 0, it returns 0. Otherwise, if the number is, so if there's a remainder, so what this does is it checks the remainder. So if there's a remainder when divided by 2, we apply the same function to omega minus 1, and we add 1 to the number of steps. So the del here, this is the recursive call, and otherwise we just do 1 plus omega divided by 2, and the number of steps for 14 gives 6. And this is a fairly simple recursive solution. Also, maybe I should have written it in a different way, so maybe like this. So if omega is equal to 0, we are already there, 0 steps there. So if there's a remainder when omega is divided by 2, then we return 1 plus the number of steps it takes to transform the preceding number, and otherwise it's just 1 plus the number of steps that half the number takes. Sorry about that, I clicked the wrong shortcuts on my keyboard. So this is the solution I wrote, and this is a recursive one. But something we can also notice is that the number of times we need to divide by 2 is going to be related to the logarithm of the number in base 2. So let me go ahead and go to the example again. Notice that the 14, we divided it 1, 2, 3 times, and if we do the logarithm of 14 base 2, it's 3 point something. So the floor gives me the 3, the number of times we had to divide. And also, if I take a look at the binary expansion of 14, there's 3 ones in there, and those correspond to the times that we have odd numbers, because this is essentially figuring out the binary decomposition of 14, except with some intermediate steps explicitly written down. And so if I add this up, I get the number of ones there. And so I can actually write a second solution that is nicer, I think, and that's going to be, it's just going to be me figuring out the binary digits of the arguments. And notice here that the 2D code power to the minus 1 takes something on the right and gives me the binary digits. And then what I do is, I need to figure out how many binary digits there are, because that's the same as taking the logarithm, except here we get the 1 plus what we wanted, so we need to subtract 1 from that. And we also need to sum them to figure out how many ones there are. So what we can actually do is, we can do the following. We can subtract 1 from the sum and the number of digits. And so the solution with 14 is 6. And let's try a couple more. So the solution with 8 should be 4. So let's see. Actually, I don't think this will work. Yeah, I don't know why I thought it didn't work, but of course it has to work. Never mind. And then the solution with 123 should be 12. So there you have it. And we can also write this, we can write all of this tacitly. So the final thing is to do this, But first what we need to do is figure out the binary expansion of the inputs. So this is the first thing we need to do. So this is our tacit solution. And our tacit solution on 8 and also on, was it 14? So there you have it. This is one way to do it. There's plenty of different ways to solve the same problem in APL, regardless of the problem. So this one probably isn't an exception. So if you have some other solution that you want to suggest, feel free to leave it down in the comments below. Otherwise, I will see you in the next video. Bye.